right, students, welcome to our lab today. This is probably as weird for you guys as it is for me, but due to our circumstances, this is how lab's gonna be. So whenever there's time in the book where we would have a lab, this is what we're gonna be doing. You'll see me, your favorite YouTuber, up here doing the lab for you. So, our lab this week with our unit would have been all about the differences between different types of water, because the different types of water leads to different types of currents. So the first part of the lab we would have been talking about is the difference between cold water and warm water. So students, if you look at your video guide, number 1 matches what's on the board. So teachers, take a second to pause, have students fill out this section of the video guide, and go over it with them, and then restart this video. After your discussion with class, we should be able to learn and understand that cold water, if we looked at it underneath a microscope, those particles would be moving really slowly, which means that they have a really low kinetic energy. We also should understand, this is the most important part for your quiz, these densities, is that cold water has a really high density. Things that are cold are going to tend to sink to the bottom of certain liquids, or objects with high densities are going to tend to sink. And then cold water, these particles are going to be much closer together. Students, we all know how good of an artist I am. I know this doesn't show up very well. But if you had a particle box, like in the book, it shows you one of these, and I was drawing particles of cold weather, those particles would be almost touching. They wouldn't be touching, but they'd be pretty close. All basically right next to each other. I don't know if I can zoom in. Kinda. I'm sure that didn't really help, but oh well. And then in science, we like to think of things as being opposites of each other. When we did photosynthesis and cellular respiration, we said that those are opposites. If you knew one of them really well, you basically knew the other one, because you just reversed everything. Same thing's true with cold water and warm water. If I know that cold water has more or has low energy, since they're opposites, I can also say that warm water is going to have a high energy. I can also say that warm water is going to have a low density. Or I could say that these particles are going to be really far apart. And if I draw my Picasso level drawing, there's my particle box. Again, I know this doesn't show up very well, but if you added your particles, they will be really far apart. They want nothing to do to each other. They're all introverts. They're going to be as far apart away as they possibly can be. The question we'd ask then is, why does this matter? Get it? Because particles are matter. Huh? But why does it matter? That's simply because density differences are what causes currents. Our ocean currents, our surface currents, our deep currents, which we'll talk about soon. But this is the primary cause, is the density differences in water, whether it's temperature causes that density difference or salinity causing that density difference. So I'll kind of show this. So this tank here has 2 sections of water. I'm kind of going fast because I don't want this to not work. On this side we have cold water, water that's chilled. On this side we have water that's been heated up pretty close to like a rolling boil, a soft boil. So on this side, this water's cold. It's a really low temperature. We'll dye this blue just so it's easy to see. This is always hard to squeeze out. There we go. We'll let that set. That way it's easier to see in a second. And then this warm water, we'll dye it red. Looks like the scene of Jaws. And we'll give this a good mix. You see we have this divider here, so these aren't gonna mix. Maybe a little will sneak in through the bottom, but they're really not gonna mix at all right now. Actually, I want that to be a little darker, more red. Add a little bit more. But students, on your worksheet, you have, it's question number 2. Ask you, in that box that it gives you, you're gonna draw what you think is gonna happen when this divider gets lifted. Where is the cold water gonna go? Where's the hot water gonna go? Is one gonna end up on the top or bottom? They should mix together and make purple. So I'll have the video get paused for a second and then you can draw. Either use colors if you have colors or label if you have labels. Hopefully you've had time to draw. I'm just gonna lift. And then as you can see, our red water is on the top and then our blue water is forming a nice layer on the bottom. There's a word that we use to describe this movement. Because this water's settling on the top and because this water's settling on the bottom, we're basically forming 2 separate currents. I have a current up here, I have a current down here. And if I let it sit for long enough, we're gonna get something called convection. This movement of water due to this water being less dense than this one is due to convection. So if we let this sit for long enough, eventually they would mix. I'd end up having just one purple layer. But we're not gonna have this video go long enough for that to happen. Notice I have my red on the top, I have my blue on the bottom. If we went for long enough, eventually they'd mix. We're not gonna go for that long. Plus in the real world, they get heated or cooled at the equator to get warmed up or at the poles to cool down. But now, you're gonna answer question 4 on your worksheet. It says you're using your CER evidence. Make a claim from the question. Your evidence would just be this video. And then your reasoning would be what you know about density. But I think that's all for this first video. There's 2 more, so hopefully you enjoyed this enough. Please don't forget to smash that like button, to comment, subscribe. Stay tuned. Maybe we'll do more of these if this is something people like.